As people trying to make sense of the world, we make observations and form our interpretations of them. A powerful method for interpreting our observations is to quantify what we observe into numerical data and make graphs from them. Graphs are very useful for interpreting data as they give us a visual representation of the relationship between two or more variables. With graphs, we can get a clearer understanding of data collected in areas of study such as physics, biology, economics, or any time we observe relationships between variables. As powerful as graphs may seem, they do have their limitations. They may be misinterpreted or used to manipulate an audience in order to agree with a particular viewpoint by being unrepresentative of the phenomena that they claim to represent.
When making graphs, we typically have two variables whose values correspond to the horizontal and vertical axis. If one variable depends on another, we represent them on the horizontal and vertical axis respectively. This is where we could potentially run into problems. There are times when it isn't established which variables depend on which. We must be wary of the fact that correlation does not equal causality. For example, when a young couple purchases cribs, this tends to positively correlate with them having a baby in the near future. The crib was purchased first. Does this mean buying cribs causes babies to be born? Clearly not, since they had probably been aware that they were expecting to have a baby before the purchase. With just the graph alone, however, we aren't given any indication of this error. Say, for example, cribs purchased are represented on the horizontal axis, and babies per couple are represented on the vertical axis. And if someone were to show this graph to someone, perhaps a child, who knew nothing about how to read graphs and had little understanding of parenthood, they could come to a conclusion that cribs cause people to have babies. While it's understandable, clearly there's a problem with this conclusion. Another example of a potential misinterpretation is, if variable is omitted, we may mistakenly come to the conclusion of a causal connection. We may represent on a graph and notice a positive correlation between the amount of cigarette butts in bins and yellow teeth and erectile dysfunction. Could we therefore conclude that these cigarette butts cause the symptoms? Perhaps removing the cigarette butts from the bins would stop these symptoms from occurring. The missing variable in this case is the number of cigarettes smoked by the owners of these bins. Another great example of the use of graphs in economics is the representation of supply and demand of labor. This example, the x-axis is the quantity of labor and the y-axis is the hourly wage per hour. The equilibrium wage is $10, where a demand is equal to supply. The graph shows the effective minimum wage of $12. The yellow box shows all the possible legal combinations for demand and supply of labor. We can see that demand exceeds supply by $700 at $12 hourly wage. Where the demand and supply function are at $12, this represents unemployment. In this graph, it helps us visualize the effective minimum wage, which is unemployment, and it helps us prepare for unemployment by estimating the amount of unemployed. Although the graph has limitations such as not showing important factors that decide minimum wage, like the cost of living and pressure from trade unions, it also is just an estimate of supply and demand. The actual supply and demand will be different, as well as suggesting that unemployment reaching zero is impossible. Overall, this graph example is very useful for predicting effects of minimum wage and is easily understandable. However, like many graphs, it can be used to interpret or misinterpret data. There will always be data that will not correspond to the graph in real life, like straight lines, and for many situations, more information is needed to make conclusions. In conclusion, while we may know better, these are examples of misinterpreting graphs due to lack of prior knowledge about a particular topic. Many of us lack prior knowledge on many topics, and therefore, these are things we should keep in mind when attempting to interpret graphs.